Welcome to Spaceverse, your portal to cosmic adventures. The James Webb Telescope has made an absolutely mind-blowing discovery. Lights that look just like city lights, coming from a far-off place 7 trillion miles away. This incredible find has set off a buzz about the possibility of life beyond Earth. The telescope zoomed in on Proxima Centauri B, the closest exoplanet to our solar system, and spotted some truly strange and bright lights. Could these be signs of an advanced civilization? Join us as we dive into how the James Webb Telescope uncovered these exciting phenomena that could change our view of the universe forever. Distant glimpses of alien life. For ages, both scientists and curious minds everywhere have been dreaming of catching a glimpse of life beyond our solar system. Any tiny clue pointing to something out there was met with excitement. Then came the game changer. The James Webb Space Telescope delivered some amazing evidence of life in space that's got everyone talking. As it ventured into the depths of space, this remarkable telescope stumbled upon something fascinating on Proxima Centauri B, a distant exoplanet. It detected lights that resemble the city lights we see on Earth, sparking the exciting possibility of an alien city on this far-off world. This discovery has generated a surge of excitement and curiosity among scientists, as it might be the breakthrough they've been eagerly anticipating. It hints at the potential presence of intelligent beings out there, organizing their societies in ways we can only begin to imagine, with evidence now emerging. Staring at these city-like lights from a staggering 7 trillion miles away, NASA engineers are astounded and wonder how long these lights have been visible, just waiting for us to develop the technology to spot them. David Kipping, an astronomer at Columbia University, described the planet with these intriguing lights as unusually complex. Unlike most rocky planets that absorb sunlight and emit infrared energy, this exoplanet behaves differently due to its unique interaction with its host star, Proxima Centauri. This discovery by the James Webb Space Telescope underscores its significance. The telescope's capability to detect infrared wavelengths was crucial in spotting the unusual thermal signature of Proxima B, which is essential for understanding the planet's atmospheric conditions. Researchers intend to use this telescope to further investigate the atmosphere of Proxima B and assess its potential habitability. The James Webb Telescope's sensitivity to infrared light allows it to observe Proxima Centauri B even during the planet's night. Unlike many space telescopes that struggle to detect faint lights in the vast darkness of space, the James Webb Telescope can spot even the smallest glimmers of light. This makes it an ideal tool to verify whether the so-called city lights on the dark side of Proxima B are genuine. The telescope is capable of detecting any artificial light in space if it falls within a very narrow frequency band, much narrower than regular starlight. Proxima B has a dynamic relationship with its star. On the planet's daytime side, numerous solar panels capture the intense energy from the star, and its spectral edge also reflects light. As Proxima B orbits Proxima Centauri, it experiences day and night cycles similar to those on Earth, with intense heat during the day and cooler temperatures at night. The planet experiences considerable temperature fluctuations, largely influenced by its composition. For example, if Proxima B lacks an atmosphere, the temperature contrast between day and night would be extreme. Without the moderating effects of atmospheric gases or oceans, the daytime side would become extremely hot, while the nighttime side would plummet to freezing temperatures. This significant temperature variation is a crucial focus for astronomers because it provides insights into Proxima B's atmospheric makeup. The James Webb Space Telescope, with its exceptional infrared imaging capabilities, can analyze the planet's thermal emissions effectively, yielding valuable data about its atmospheric characteristics. Interestingly, the orbit of the James Webb Telescope around Earth aligns with Proxima B's orbital period, allowing for detailed observations of its day and night cycles every 11.2 Earth days. If Proxima B does have an atmosphere, the next step will be to study its atmospheric chemistry to assess its potential for supporting life. Indicators such as the presence of oxygen, water vapor, and methane would suggest habitable conditions. If these key elements are detected on the planet, it could mean that Proxima B has the potential to support life. This involves the tricky task of capturing and analyzing light that travels through the planet's atmosphere. While the James Webb Telescope is fantastic at studying planetary atmospheres, it was originally designed with other tasks in mind. It shines at measuring water vapor, carbon dioxide, and methane levels. Although it has some limitations in detecting bonded oxygen, an important sign of life, it's also equipped to search for other crucial elements like ozone, which hints at a thriving atmosphere. As scientists dive into the James Webb Space Telescope's incredible findings, our journey to explore distant worlds gets even more exciting. We're getting closer to answering the big question: are we alone in the universe? Stay tuned as we uncover more about these faraway planets and their potential for life. Exploring new worlds with Webb. While the James Webb Space Telescope has given us a glimpse into the universe, it can only observe a select number of the closest potentially habitable worlds to Earth. For a deeper dive into the atmospheres of distant exoplanets, astronomers are looking forward to ground-based observatories like the Extremely Large Telescope, set to begin operations in 2028. The ELT promises to provide clearer and more detailed data about these far-off worlds, enhancing our understanding of their potential to support life. Scientists are eagerly anticipating the launch of the ELT and its contributions to our cosmic exploration. In the meantime, the James Webb Space Telescope remains a key player in our quest to uncover the mysteries of distant exoplanets. Despite its limitations, Webb continues to offer groundbreaking insights that could reshape our understanding of what exists beyond our solar system, both now and in the future. Looking ahead, researchers have exciting plans for the space telescopes of tomorrow. They aim to minimize the bright glare of stars, which is akin to using your hand to shield your eyes from the sun on a bright day. By reducing the starlight, these future telescopes will get a clearer view of the faint light reflecting off distant planets. This will allow scientists to study the planet's atmospheres and assess their potential for supporting life. But tackling this challenge is no easy feat. Scientists face the challenge of distinguishing between gases produced by life forms and those resulting from natural planetary activities, such as volcanic eruptions. They're dedicated to understanding these distant worlds better, ensuring they accurately identify genuine signs of life rather than mistaking natural processes for biological ones. The James Webb Space Telescope is offering a glimpse into what future studies might reveal. As we push the boundaries of space exploration and knowledge, we're getting closer to grasping the complexity of the universe and our place within it. Since the dawn of humanity, we've wondered if we're alone in the cosmos, a question that continues to inspire scientific inquiry. Today, the James Webb Telescope is actively exploring various planets and moons to determine if any could harbor alien life. Many believe that aliens might exist somewhere in the vast universe, waiting to be discovered. To address this age-old question, American astronomers Jill Tarter and Thomas Pearson launched the Search for Extraterrestrial Intelligence project in 1984. They established a non-profit organization to listen for radio waves from space, as radio waves can travel long distances without diminishing. To achieve this, they used the Allen Telescope Array in the California mountains, equipped with 42 radio telescopes dedicated to this mission. Despite over 30 years of searching, SETI hasn't yet detected any definitive alien radio signals. However, Jill Tarter remains optimistic. She believes that with today's technology, we might finally make a breakthrough, and has even expressed hope that everyone on Earth will join in this thrilling quest for cosmic companionship. Recently, excitement has been sparked by NASA's report that the James Webb Space Telescope might have detected city-like lights on a nearby planet. The JWST is currently our most advanced tool for exploring space. Positioned a million miles from Earth, it sends back detailed information about the universe's oldest regions. Designed to capture details previously missed, it enhances our understanding of how galaxies, stars, and planets form. Astronomers are leveraging the JWST's cutting-edge technology, including its incredibly sharp camera and specialized filters, to analyze the subtle colors around stars and planets. The telescope is crucial for examining the physical and chemical properties of distant locations by detecting specific light wavelengths. Beyond observation, the JWST is actively searching for the faintest signs of life in planetary atmospheres with its unparalleled ability to probe space and time. The JWST has already made groundbreaking discoveries, such as revealing more mass in the universe than previously thought, hidden within massive galaxies. These findings have prompted scientists to reconsider theories about the universe's origins and evolution. With each new revelation from the JWST, our quest to understand distant planets and the potential for life beyond Earth becomes more profound. New clues in the search for aliens. The James Webb Space Telescope is taking humanity further into space than ever before, providing fresh insights into distant worlds and potentially answering some of our biggest questions about these far-off planets. Just 20 years ago, our understanding of exoplanets was limited, but since then, astronomers have identified over 4,000 planets orbiting stars beyond our solar system. This impressive achievement demonstrates how much we've expanded our curiosity and technology. NASA believes this is only the beginning, with potentially trillions more exoplanets waiting to be discovered. The quest for extraterrestrial life continues with excitement. Occasionally, scientists get promising leads suggesting that we might be on the verge of a breakthrough. For instance, when the Galileo spacecraft visited Jupiter, it unexpectedly detected a potential sign of life, the vegetation red edge. This biosignature, which reflects how light interacts with plant life, was a major find, offering a new approach to detecting life beyond our planet. With the virtual reality engine in play, the James Webb Space Telescope is poised to delve deeper into the search for extraterrestrial life. It will map out the orbits of planets within the habitable zones of their stars, where conditions might be just right for life. If the VR picks up on certain signals, it could point us toward potential signs of intelligent life beyond Earth, sparking a new era of space exploration that ventures into the farthest reaches of the cosmos. Imagine sunlight streaming through a planet's atmosphere, splitting into different wavelengths as it interacts with atoms and molecules. This process creates a unique spectral signature, like a cosmic fingerprint, that scientists can analyze using spectroscopy. The JWST is expected to capture this starlight as it filters through planetary atmospheres, providing crucial insights into their composition. This capability makes the JWST an essential tool for understanding the atmospheres of distant worlds, and could be the key to unlocking the mysteries of extraterrestrial environments. Planets similar in size to Earth often have atmospheres with a mix of carbon dioxide, nitrogen, and oxygen, which could indicate potential habitability. However, the discovery of unusual or rare compounds might reveal even more intriguing possibilities. For instance, finding chlorofluorocarbons in the atmosphere of a distant planet would be a clear sign of intelligent life, as these chemicals are typically associated with human activities on Earth. Such a discovery could greatly expand our understanding, offering new avenues for exploring planetary atmospheres and the potential for advanced civilizations far beyond our solar system. The search for extraterrestrial life pushes us to reconsider our assumptions about what makes a planet suitable for life. While we often imagine life requiring a temperate climate, the reality could be much more diverse. Extremophiles, microbes that thrive in extreme conditions, challenge our conventional ideas. These organisms can survive in environments with boiling temperatures, extreme acidity, and other harsh conditions that would be inhospitable to most life forms. Their resilience highlights the incredible adaptability of life and suggests that we might find life in places we least expect. As we continue to explore, these new possibilities remind us of the vast and varied nature of the universe and how much more there is to discover about life beyond our own planet. Exploring life in unexpected places. Considering the immense scale and variety of space, our quest for extraterrestrial life must be both expansive and inclusive. While focusing on planets that resemble Earth and orbit stars similar to our Sun is a good starting point, it's crucial to also explore less conventional scenarios. For instance, examining exoplanets orbiting red dwarf stars, which are abundant throughout the universe, is equally important. Although red dwarfs are cooler and dimmer than our Sun, their unique characteristics make them intriguing candidates for life studies. Their long lifespans provide ample time for life's slow and complex evolution. Take the TRAPPIST-1 system as an example. This system features a faint red dwarf star with 7 rocky planets orbiting it, 3 of which are considered to be in the habitable zone, where liquid water could potentially exist. Despite its smaller size and cooler temperature compared to our Sun, the TRAPPIST-1 star emits a gentle light that could still support life. By analyzing the light from this star, scientists aim to gain insights into the possible living conditions within the TRAPPIST-1 system. The James Webb Space Telescope has determined that this star is located approximately 41 light-years away in the constellation of Leo, making it a promising candidate for further exploration. Ward Howard, a NASA Sagan Fellow from the University of Colorado Boulder, is thrilled about the new discoveries made with the James Webb Space Telescope. He highlighted that this is the first time we've had the capability to search for planets around other stars with secondary atmospheres similar to Earth's. Howard emphasized the importance of understanding these stars to gain insights into their planetary systems. Proxima Centauri stands out in our cosmic neighborhood due to its close proximity, only about 4.25 light-years from the Sun, making it the nearest star to Earth. Its faint glow makes it difficult to observe from Earth, meaning any potentially habitable planets would need to orbit very close to Proxima Centauri to maintain suitable conditions for life. On August 24, 2016, astronomers made a groundbreaking discovery: a planet with 1.3 times the mass of Earth, located in the habitable zone of Proxima Centauri. This zone is ideal for melting ice and possibly supporting life. Proxima B, the planet in question, orbits its small red star at a distance of just 4.6 million miles. This close orbit exposes it to significant hazards that could challenge the potential for life. One of the biggest challenges for Proxima B is the intense solar winds from its host star, Proxima Centauri. These powerful winds could potentially strip the planet of its atmosphere. Yet, despite these harsh conditions, Proxima B receives enough sunlight to stay warm enough for liquid water, an essential ingredient for life as we know it. The close orbit of Proxima B results in tidal locking, meaning one side of the planet always faces the star and is bathed in constant daylight, while the other side is in perpetual darkness. This creates a dramatic contrast between the two hemispheres. One could be continuously illuminated and potentially warm, while the other remains in eternal night and could be freezing. This is somewhat similar to the way the Moon always shows the same face to Earth. Despite Proxima Centauri's relatively small size compared to our Sun, it still provides enough light and heat to possibly support conditions that could harbor life, similar to those on Earth. So, could these mysterious city-like lights on Proxima Centauri B be a sign of advanced alien civilizations? Or is there another explanation we haven't thought of yet? Share your thoughts in the comments below. And that's it. Thanks for exploring the cosmos with Spaceverse. Could those mysterious city-like lights on Proxima Centauri B be signs of alien life? Share your theories below and hit that subscribe button for more space discoveries. Until next time, keep looking up.